Okay, so let's start our lecture today. So, yeah, I think last time we concluded that the conjugate scenario cannot happen, right? So if you have, let's say, omega 1 here, and then you have omega 2 right here. Oops, they are there. Okay, so yeah, so I cannot have the conjugate of omega 2 and then add omega 1. It's not gonna happen. So maybe my analyzation becomes so can they actually be can their bond be controlled by something? So okay, so let me think. Theta pi. Okay, let's see whether this angle how will work. So theta and pi plus theta. So okay. So I think this is just take the negation, right? Yeah, so e to the 1 over and then pi plus theta, which is yeah, so plus theta I pi plus theta times 2. Yeah, so this is not true. So okay, I think I can only go diagonal, like refraction based on the origin, but I cannot do any reflection on the either x or either real or the imaginary axis. I cannot do that. So therefore, I cannot get the condition that they cancel. So yeah. I mean, can I do any projection here? So so can I do like the omega 2 projected on the imaginary plane, right? Yeah, so can I do any projection down here? So what will happen if I did a projection here? Okay. Let's see. So, okay. So let's do a two. Let's imitate a square of those two, right? So, so let me just erase this one. Okay. So, let's see. What happens if I draw a line here? So, so this is the angle. This is a, yeah. Okay, I think shoot. Yeah, so the angle is not exactly the same. Yeah. Let me think. Sorry. Okay. So I know that these two triangles. Okay. So I know that these two triangles and this one. So I think they are similar triangles, right? Actually, I think they are exactly like you can yeah. I think they have exactly like the same. Yeah. So they are. How gonna say? Yeah, they are like the same triangle. Yeah. I think. Let me see. So why they are the same triangle? Because yeah. So what do they mean by triangle? Yeah. So what uniquely determines the triangle here? The angle and I think maybe angle and the sides. What do you mean by same triangle? I think some length, same angle, same length, right? So basically, if you look at this, let's name the vertex. Okay. So this is A, this is point B. Okay. And then this is ABC. Okay. So and then wait. Okay, I don't think these are the same triangle here, but okay, I draw that. I'm drawing the way that they are the same, but they are not really the same. Okay. Okay. So, but I can say that their angle are exactly the same. Okay. Yeah. So their angle are the same. Well, why their angle are the same? Okay. I don't think I have. Here, so here is 2 omega 1 and 1 omega 2. Okay, so wait a second. Yeah, so let me think. Okay, so this angle and this angle are the same, right? Okay. What else do I know? So this angle and this angle are the same. Okay. Let's try to do this one. So this angle. Okay. So this angle and this angle are the same. Yeah, so this angle and this angle are the same. And then this angle and the angle here is the same. Okay. Yeah, so very apparently these two are not really the same angle. So yeah. I think it just the way I'm drawing it make them seem the same. But if I draw it in a very different way, then I promise you they are not the same. Okay, there's no reason to believe that these two triangles are the same, have the same angle, or like at least similar angle here. Wait, how did I show in the triangle case? Wait, how did I show? Let's say you have this triangle here. Yeah, so how do I really show in the rectangle case? I really forgot. So do they cancel out? Oh, I think in the rectangle case, so this angle cancel out with this angle. Yeah, this is what I remember. Okay. Yeah, so somehow these four angles, these 4 points, they all cancel out. Because they have the conjugate symmetry and also the real symmetry. Okay. 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 Wait. I was confused again. So, okay, so this is theta. Okay. So e to the. I think I made a mistake there. Okay. So this is the angle theta. So. So I have 1 over r squared, and then I have 1 over. Okay. E to the 2 I theta. Right. And then plus 1 over e to the I don't know why I just cancel them out. So I think these are e to negative theta. So wait. Let me do this carefully. So okay, so this is the r here. So this A is B. Okay, so 1 over A squared plus 1 over B squared, which is equal to 1 over R squared e to the R e to the I theta squared, okay, plus 1 over R e to the I negative theta squared. Okay. R squared e to the 2I theta plus 1 over R squared e to the, okay. So this is negative I, okay, so negative 2I theta, okay, so this is equal to 1 over R squared, okay, so e to the negative 2I theta plus e to the 2I theta, okay, so these two doesn't cancel out, okay. Okay, so I think what cancel out is plus pi stuff, right? So I think maybe these two are cancelled out. So this is pi minus theta. Wait. Yeah, they only cancel out if the difference is the pi, right? Oh. Okay, so let's see. So this is C. Yeah, so this is the same point as this one. Okay. Because when you square them, they are the same. Okay. Oh. So this 4 point actually doesn't cancel. Yeah. So, okay. Okay, let's go back to this argument. Yeah, so how do we handle the square case then? Um, So it's here, what's really happening is that you doubling it, right? So you double the angle, and then you put a negative sign in front. Yes. So you're doubling this angle. Oh, okay. You're doubling this angle, and then you take a minus sign. Yeah, so what do you mean by take a minus sign? I think it's just a reflection based on the x-axis, right? The real axis. So you double it, and then you take a reflection based on the x-axis. Yes. Okay, sorry, I have to end today. So yeah, I'll try to figure out a way next time.